Okay, let's go back to this diagram here. And there is a interesting question still remaining. What is the point Q? Q, Q, Q. What is that? Well, here's how I'm going to attack it. I'm going to do something kind of funny. I'll put the origin here. You know, I could put the origin here and it wouldn't make a difference. Or I could put the origin here. It wouldn't make a difference. It'll make my diagram unpleasant, but it will give me the same answer. So I'll put the origin here, and I will try to find this vector lowercase q. And I will say to myself, lowercase q, I can get this vector by, first of all, doing from the origin p naught. So do this vector first. This is lowercase p naught. And then I can add, ooh, too much coffee. Wow, look how wavy that line is. Anywho, this vector here is P0, capital P0, Q. Okay, this triangle here says to me that lowercase q is lowercase p naught plus p naught q. All right, so q is going to be, what's p naught? Well, it's just the vector corresponding to this point, 2, 0, negative 1. And P0Q, this is the projection we pretty much just found. Projection onto D of U, which we found in our calculation, which I have over here. So we found it here. So tracing it through, I see that it's right here. So I can copy it into my calculation down here. This fraction is minus 2. And then 1, negative 1, 0. Okay. Following up here, I get 2 minus 2 is 0. And then I get a 2. And then I get a minus 1. So therefore, the point Q is 0, 2, minus 1. That is the point on the line L that is closest to P. Okay, I want you to try one of these. Here's the answer down here. There are 2 answers. Okay, so we got a new line and a new point. Give it a shot. Let me know how it goes. I know it's a long calculation, but you will find that a little effort put here pays off in spades.